counterclockwise, the convention is what? Don't say convention. If I pick up clockwise positive, then counterclockwise should be taken negative. Let me take the next condition. Yeah. Okay, spotlight. Yeah, this will be correct position. So we have a spotlight here. Spotlight source. Where do we use spotlight? I think you go to the some events. A person has to be highlighted, no? Particularly some glamorous events, if you go there, no? A person has to be highlighted. So what we do, you can say the function hall or whatever be there where the particular event is going on, that will be dark. The person who has to be highlighted, what happen on him, what happen, a light will be focused, no? Spotlight it is called. So such a spotlight which will produce a beam of light, thin beam of light. It is made to focus on a floor. This S is the spot. I'm going to rotate this spotlight source. Then with what speed the spot will move on the screen? No. With what speed the spot will move on the wall? The speed of spot is when the beam of light makes an angle theta with vertical. This particular spotlight, the source will be rotating about z axis. So if this is x, this is y. About horizontal axis, it will be rotating. So what do you mean by this horizontal axis? So if this is the x axis, it will be rotating this source. I'll be rotating it about what? About z axis with an angular velocity omega. So therefore, what is omega? Omega should be equal to d theta by dt. So let x be the distance. So let me go for triangle. Tan theta equal to opposite by adjacent. Look at this part. What is tan theta? Opposite by adjacent. So what is question that is asked? This speed of the spot on the floor. Okay, let me rearrange that. X equal to h tan theta. How does the spot will move? I think the spot will start moving in this direction. So the direction of so let me differentiate this. Differentiation of derivative of tan theta. Dx by dt should be equal to the time derivative of tan theta. So dx by dt is the speed of the spot. H derivative of tan theta, secant square theta, d theta. D theta by dt is what? The angular velocity. Well, spot will move with a, see, the spotlight source I'll rotate with a constant angular speed omega about z axis. What will be the speed of spot? The speed of spot will not be constant. In fact, it will be depends on theta. Getting this one, it depends upon theta. So don't think that it will move with a constant speed. No, it will be continuously varying. It all depends on, see, h and omega are constant. So secant square theta. Okay, this theta will be variable, no? So definitely the spot will not have a constant speed. Will move with varying speed on the floor. No, sir, we didn't understood. Okay, you do one thing. Let me, I'll explain through. Look at this arrow. So earlier now the spotlight is here. So as I rotate the spotted beam, no, the spot what happened will be moving. The spot is going to move like this as I rotate. Okay, once again look at this one. So now at t equals 0, okay, the spot will be at point S on the floor. As I rotate that source, the spot what happen will not so will we should move along the floor only. It will be like this. Look at the tip of arrow. The tip of yellow color arrow is what? The spot. How it should move? It should move along the floor only. So look at the theta. Theta is varying. So sir, why d theta by dt? Look at the theta. Will be theta constant? No. But whereas h will be constant. And x is also variable. So earlier the spot was at a distance x. Now the x is also variable. Let me, okay, what is x? Even this x is also variable, no? And but whereas h will be constant, why it will vary? The spotlight source will be at a constant height from the floor. Fine. So theta and x are variable. That's why we have differentiated it. And dx by dt is what? The speed of the spot.